Welcome to the session on radians, trigonometric equations. The objectives for this session are to solve trigonometric equations in radians. Earlier in the course, we looked at solving trigonometric equations in degrees. We can solve trigonometric equations in radians using the same methods. Let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. We are required to find the solutions of the equation cos theta equals 0.3 in the interval 0 is less than or equal to theta is less than or equal to 2 pi. So here's a sketch of cos theta between this interval. Here's y equals 0.3. Using a calculator, we find that theta equals 1.266 radians, and we can see this in our graph as well. However, there are other solutions in this range also, or in particular one other solution. So notice that the distance highlighted is 1.266 on the graph, and by symmetry we have the point on the other side of the graph is 2 pi minus 1.266. So, of course, cos theta equals 0.3 is where the line y equals 0.3 intersects the curve. And therefore, the solutions are theta equals 1.266 radians and theta equals 2 pi minus 1.266 radians, which is equal to 5.017 radians. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. We are required to find the solutions of the equation cos theta equals a half in the interval 0 less than or equal to theta less than or equal to 2 pi. From memory or your calculator, you will find that theta equals pi by 3. However, there are other solutions in this range. In particular, there's one other solution. We're going to find this by using the cast diagram as shown on your screen. So theta equals pi by 3 is the principal solution. And so the other quadrant in which cos is positive is the fourth quadrant as highlighted. So cos theta equals a half is positive in the first and fourth quadrants. Therefore, theta equals pi by 3 and 5 pi by 3 as shown in the diagram. Now let's take a look at another example. Again, pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. We are required to find the values of theta in the interval 0 less than theta less than or equal to 2 pi that satisfy the equation sin theta equals cos theta. Of course, sin theta equals cos theta in this interval implies that sin theta over cos theta equals 1, and therefore tan theta equals 1. However, tan inverse of 1 equals pi by 4. Again, if we use the cast diagram, we know that there are only two quadrants where tan is going to be positive, namely the first quadrant as highlighted and the third quadrant. And therefore tan theta equals 1 implies that theta equals pi by 4, which is the principal solution, or theta equals 5 pi by 4, and that was obtained by adding pi by 4 to pi, as shown in the diagram. We're now going to take a look at some important features of trigonometric functions. In the sine and cosine curve, we know that the maximum is 1 and the minimum is -1. For the tan curve, there is no max or min. In this part of the video, we're going to solve more tricky trigonometric equations, such as sin n theta equals k, cos n theta equals k, for k between -1 and 1, and tan n theta equals p, for p in the real numbers. Pause the video and have a go at this example. Press play when you're ready to view the solution. So let's solve this. We're required to solve cos 2 theta equals 1/2 in the interval 0 less than or equal to theta less than or equal to 2 pi. Begin by letting x equal 2 theta and then solve. So we have that cos x equals 0.5, which hopefully will look quite familiar to you. When x equals 2 theta and theta is between 0 and 2 pi, we have that x is between 2 times 0, which of course is 0, and 2 times 2 pi, which of course is 4 pi. So the interval for x is 0 less than or equal to x less than or equal to 4 pi. The calculator, or from memory, gives us that cos inverse 0.5 equals pi by 3. And therefore, x equals pi by 3 in the first quadrant. However, there are of course other solutions in this interval, namely 5 pi by 3 in the fourth quadrant, and up to 4 pi, there are other solutions as well. Here we've listed all values for 2 complete revolutions. So 7 pi by 3 is obtained by adding 2 pi to pi by 3. And 11 pi by 3 is obtained by adding 2 pi to 5 pi by 3. And therefore 2 theta equals pi by 3, 5 pi by 3, 7 pi by 3, and 11 pi by 3. And therefore we have that theta is equal to pi by 6, we're of course dividing by 2 now, 5 pi by 6, 7 pi by 6, and 11 pi by 6. We're now going to take a look at solving quadratic equations in sine, cos, or tan. This may give rise to 2 sets of solutions. So for example, if we consider the equation 6 cos squared x minus cos x minus 2 equals 0, and we factorize, we obtain this expression here. So if we set each factor equal to 0, we have that either 2 cos x plus 1 equals 0, or 3 cos x minus 2 equals 0. Let's now take a look at another example. Solve for theta in the interval the equation sine squared of theta minus pi by 4 equals 1/4. in the interval 0 less than or equal to theta less than or equal to 2 pi. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. Of course, sine squared theta minus pi by 4 equals 1 over 4 implies that sine theta minus pi by 4 equals either plus or minus a half. So we have either of these two expressions highlighted in red. If we consider sine theta minus pi by 4 equals plus a half, then we have that theta minus pi by 4 equals pi by 6 as one of the solutions. Now sine, of course, is positive in the first and second quadrants. Therefore, theta minus pi by 4 equals pi by 6 or 5 pi by 6, which of course is pi minus pi by 6. When sine theta minus pi by 4 equals minus a half, then we have that theta minus pi by 4 equals minus pi by 6. Sine is negative in the third and fourth quadrants. Therefore, theta minus pi by 4 equals either 11 pi by 6 here. Here, of course, we've subtracted pi by 6 from 2 pi, or 7 pi by 6, which is pi plus pi by 6. And so if we solve for theta, we obtain that theta equals 5 pi by 12. Here, of course, we've solved the equation theta minus pi by 4 equals pi by 6. Or we obtain theta equals 13 pi by 12 from the equation theta minus pi by 4 equals 5 pi by 6. Or theta equals 25 pi over 12, which is obtained by solving theta minus pi by 4 equals 11 pi by 6. Or theta equals 17 pi by 12, which is obtained by solving theta minus pi by 4 equals 7 pi by 6. Notice that theta must be in the range 0 less than or equal to theta less than or equal to 2 pi. However, out of all these solutions, there is one solution which is not in this range, namely 25 pi by 12. So we exclude this from our set of solutions. So the solutions for theta are those highlighted on your screen in red. This brings us to the end of this session. If you have understood its contents, you should be able to solve trigonometric equations in radians. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.